So we're going to pick up today with lesson 8.5. We're going to move into simplifying radical expressions. And this is a lot of what we already have done. I know you just reviewed this. Most of these concepts, we're going to add a little bit of multiplying and dividing today as we simplify these radical expressions. But for the most part, this should be a review of what you've seen. Um, we do have this product property of square roots. And what this property is going to tell us is that if we have numbers a and b, and we have the product, or the square root, I should say, of the product of a times b, then this is equal to the square root of a times the square root of b. So it looks something like this. So if we have a product under a square root symbol, we can rewrite it as the square root of the first factor times the square root of the second factor. What this will then allow us to do is, by breaking these into two separate radicals, I can simplify them separately. Or we could start with this product and work our way this direction and take this square root of a times square root of b and think of it as a times b. We will use this technique today as we start to simplify these radical expressions. The other property we have is this quotient property of square roots. And the quotient property, of course, quotient is telling you guys division. And division, again, is a fraction. So this just says that if I have numbers a and b, and I have the square root of a divided by b, I can separate that into the square root of a divided by or over the square root of b. And we've worked with this concept already, but we'll use it again today to help us simplify. So again, to summarize this one, if I have the square root of this fraction, which we think of as a division problem, a divided by b, I can think of it as separating it into the square root of a over the square root of b, and then I can simplify these two separately. Again, just like we did up here, I could start with this part of the problem, square root of a over square root of b, and move it back in this direction and write it as a square root over this fraction. We usually, or we will use this either direction. That'll help us as we simplify, and you'll see examples of that coming here soon. So first of all, let's talk about applying this product rule that we just did. And this is simplifying radical expressions. It's the square root of 5 times the square root of 48. So what we'll do is just like what we had done before. The first thing I want to do is I want to break this 48 down into a product of primes. So we go off to the side, we take our 48, we think of that as 8 times 6. The 8 is 2 times 4, the 6 is 2 times 3. This 4 can then be written as 2 times 2. So when we're done breaking down 48, we're going to have 2 to the 4th times 3. So this now becomes a square root of 5 times the square root of 2 to the 4th times 3. Now, because this is a product, I can take these now and put them all under one radical symbol. And I'm going to try to write these again to the second power. Remember, our rule here is our index number is 2. So we want to write these to the second power. So I'm going to think of 2 to the 4th as 2 squared times 2 squared. I then have times 3 times 5. Okay, we know that the square root cancels the squares, so that each of these 2's come out. The 3 and the 5 stay underneath. And then we'll simplify what we have left, the square root of 4 times the square root of 15. So that's using the product rule to simplify these radicals. Another example, square root of 8 times square root of 12. Take our 8 and break it down. 2 times 4, 2 times 2, so 8 is 2 cubed. 12 is 2 times 6 and 2 times 3, so 12 is 2 squared times 3. So when I look at them individually, my 8 became 2 cubed, so it's the square root of 2 cubed. The 12 became the square root of 2 squared times 3. Now what we'll do is use our product rule and say, well, we're going to be able to put all of these factors together under one radical symbol. And when I take 2 cubed times 2 squared, I add exponents. So this becomes 2 to the 5th times 3. And then because we're dealing with a square root index number of 2, I'm going to think of 2 to the 5th as 2 squared times 2 squared times 2 times 3. And then the square root cancels those squares, so the 2's come out. That 2 and the 3 stay underneath. I wind up with 4 square root of 6. So the simplified answer here is 4 square root of 6. So I'm using my simplification properties of breaking numbers down, and I'm using the product rule to combine them. Okay. How do we handle the quotient concept? Well, it's the same idea here. Square root of 24 over 27. If you guys remember, neither one of these is a perfect square number, so it doesn't help us in this format. So what we'll go ahead and do is reduce the fraction first. Take 24 over 27, divide them both by 3, you get 8/9. At this point, what we'll want to do is, it's never considered to be simplified if you have a fraction under a radical. So we're going to separate it into the square root of 8 over the square root of 9. Okay. Square root of 8 is 2 cubed, or I should say 8 is 2 cubed. 9 is 3 squared. Okay. So 2 cubed is going to become 2 squared times 2. Index number of 2 in both cases means the 2 and the 3 are going to come out, and the square root of 2 is going to remain on top. So this square root of 24/27 is equal to 2 square root of 2 over 3. Those two are going to be the same. And then we just go through our process of, this is just reducing a fraction. That's no big deal. And then we can't leave a fraction under a square root symbol, so we separate and simplify. Okay, another example, 75 over 20. We're going to think of that, reduce the fraction, 15 over 4. Okay, can't leave a fraction under a square root symbol, so it's going to become square root of 15 over square root of 4. Square root of 15 over 2 squared. 15 breaks down to 3 times 5, and neither of those factors is a number squared, so that I didn't break them down. I just left it as square root of 15, and this becomes square root of 15 over 2. Sometimes the number won't break down, and you'll just leave it as a square root of 15 over 2. Okay, so that's a little bit about using our division property, our quotient property, if you will. Now moving into some more of our product rules, but now we're looking at cube roots. So now we've changed the index number to a 3. And what that should mean to us now is we're looking for base numbers to the third power under our square root symbol, or our cube root symbol, excuse me, to allow us to bring numbers out. So the process remains the same. We better take our 36 to start with and break it into a product of primes. 6 times 6. Each one of those is 2 times 3. So we know 36 is 2 squared times 3 squared. That's just a 2 under there. So we're going to leave it like that. Cube root of 2 times the cube root of 2 squared times 3 squared. Now, because we're multiplying and the index numbers are the same, I can take this value and bring it underneath with what's already here. So that's going to give us 2 cubed times 3 squared. And then the cube index number 3 matches the cube here, so we're going to be able to bring a 2 out. This 2 does not match that 3, so that's got to stay underneath. So it's going to wind up being 2 cube root of 9 as a simplified answer. Got to make sure we keep our cube root concept attached the whole way through. Another example of these, cube root of 16 times the cube root of 20. So our first step is always to break these down. So 16 we know is 4 times 4. It's going to give me 2 times 2 and 2 times 2. So 16 is really 2 to the 4th power. 20 is 5 times 4, and then the 4 is 2 times 2. So if I take these radicands, which are the numbers underneath, and I write them as a product of primes, it looks like this. Cube root of 2 to the 4th times a cube root of 2 squared times 5. Because I'm multiplying these radicals together, I can bring what's underneath the symbols together. That's going to give us 2 to the 4th times 2 squared is 2 to the 6th times 5. Because it's a cube root, I want to write things to the third power. I want to write my base numbers to the third power. So it's going to give me 2 cubed times q cubed times 5. And then the index cancels the power. So those 2's will come out. 5 stays underneath. I wind up with 4 cube root of 5. Simplified answer. Now, what if we throw variables under here along with our numbers? Doesn't really change things for us. We go about this process in the same way. We're multiplying these together, which means we can combine these under one radical symbol, but I'll break them down separately first. So break down our 45. 9 times 5, 9 is 3 times 3, so 45 is 3 squared times 5. 32, 4 times 8. 4 is 2 times 2, 8 is 2 times 4. This 4 is 2 times 2, so 32 is 2 to the 5th. So I'm going to replace the 45 with 3 squared times 5. Now I'm going to replace this 32 with 2 to the 5th. So my numbers now have changed. The variable parts are staying the same. All right. Because we're multiplying these together, then I can take this product and put them all under one symbol. So that'll give me 2 to the 5th, 3 squared 5. None of the numbers I got to combine anything. But the variables, k to the 4th times k to the 7th is k to the 11th. Okay. M to the 10th times m to the 3rd is m to the 13th. So now I have combined my two radicals, cube roots, and now I want to rewrite them as base numbers to the 3rd power. So 2 to the 5th becomes 2 cubed times 2 squared. That gives me the 5 2's that were here. 3 squared, 5 stays the same. K to the 11th is k cubed, k cubed, k cubed. That's 9. K squared is 10, 11. Okay, m to the 13th is m cubed, m cubed, m cubed. Okay, 4 of those, that's 12, and then one more m is 13. So that accounts for everything. And now the cube root cancels the cube. So anything written to the 3rd power now can come out from underneath. So I'm going to get the 2, 3 k's, 4 m's, and then those are gone. And then what's left underneath will be the 2 squared, the 3 squared, the 5, the k squared, and the m. That's all left underneath because that wasn't written to the 3rd power. Simplifying, 2k cubed, m to the 4th. If I multiply all this together, I get 180 k squared m. So it breaks down pretty simple. Just follow the process. Write things out, follow the process. Okay. That's not supposed to be there. Let me get through that. Okay, last example here. So this says to simplify the cube root of, now we have a quotient under here. All right, so how do we handle our quotient? Well, first things first is to break the numbers down. 15 is 3 times 5, so we know that. 81, 9 times 9, 3 times 3, 3 times 3. So 81 is 3 to the 4th power. All right, so just replacing my numbers now. 15 is 3 times 5. 81 is 3 to the 4th. I've left the variables all as is. Now, before I separate these, I want to reduce. Okay, so if I look at common bases, I got a 3 to the 1st power up here, a 3 to the 4th down here. When I cancel those out, I'll have 3 to the 3rd in the denominator. I got x squared, x to the 5th. When I cancel those out, I'll have x cubed in the denominator. And then these values will remain in the numerator. So it'll look like this: 5 y cubed z to the 4th. This 3 canceled that to give me 3 to the 3rd. X squared, x to the 5th cancel, give me x cubed. So that simplifies here. Now I'm going to separate because you can't leave it as a fraction under a radical. Okay, anything to the 3rd power now gets brought out. So the y and the z in the numerator come out. 5 in this z will be left. The 3 and the x come out of the bottom. Now I've taken care of all my powers and I have a simplified answer. So that, guys, is applying the product and the quotient rules to help simplify radicals. Okay, so tonight's homework will be on Alex, and please get that assignment done. You guys are doing great getting the work done. You got unlimited opportunities to work through that assignment and get everything correct. So continue to work on those. All right, we'll talk to you soon.